So welcome to the fourth video in this introductory section on B06 using Python packages. Now we're going to look at regular expressions. So these are regular expressions. These are patterns that we can match potentially, and they might have some sort of meaning that's relevant for our work. So what we're saying is that we're looking at patterns, and that is kind of a synonym for the expression here. If pattern is a regular, some sort of sequence that's of interest to us, we can check for it, and that's kind of what we're looking at here. It's kind of similar then notionally to if-else statements. We're saying if there's a pattern, do something after this. The things that we match on could be something simple like a particular sequence of letters. It could be a number. And then what we also have to note is that not only can it be a mix of letters and numbers, but also that we can include special characters in there using this symbol. So matching special characters can sometimes be tricky as well if they contain several special characters together. For pattern matching, we have to remember that we might have a variable, a list that's declared, and we might follow that with a function that acts on this list. So we might have a functional dot replace, which takes in three arguments. Firstly, the pattern, the replacement, and then an optional one that we don't necessarily need, the number of matches. So if we some string with pick a string of characters like this here, we can say s.replace and say that I want to match this pattern, which is simply a space, a single space, and replace it with a dash, horizontal dash here. So you see there, now we have 1, 2, 1, 2, 1, 2 with the dashes all the way through. If we say replace the space with nothing, so there's actually nothing inside these quotes here, we'll just get 1, 2, 1, 2, 1, 2 like that. And then finally, if we say the number of counts that we want to do, and we replace it with xxx here, we'll get replace 1 with xxx here, we'll get 1 xxx2, xxx2, and then 1 at the end. Because for the third one, we've already replaced it twice, and we don't want to replace it a third time. So you can see as well that Python automatically adds a space between these variables at the end. If we want to look at a literal specific match, such as we want to match exactly this thing of \n instead of a new line, we could also use the R character to make this a literal match with quotes, the pattern we want in quotes. So there's a bunch of special characters that we need to be aware of that can be used in patterns to match, and this is without backslash. So a full stop will match any character except a new line. Circumflex matches the string start. $sign matches the string end. Asterisk matches any number of the previous regular expression. So that can be from 0 up to infinity. Plus is the same, except has to find at least one instance of that exact irregular expression from 1 to infinity. And the question mark finds either 0 or 1 numbers of that regular expression. So these are special ones that we add into constructs like this instead of the horizontal dash to have a different pattern to match. There's other examples of matching a horizontal dash with a backslash in front because this is a special character. The same for matching a tab space, \t for tab, \s to match any space, including spacebar space, tab space, or new line. And then we have an example here. If we have a pattern match AB asterisk at the end, that will match all these variations of those matches. So match A without any B, AB, ABB, A with 3 Bs, A with 4 Bs, A with 5 Bs, A with infinite Bs. In the same way, AB plus matches all the ones above except ones without a B only. And the AB question mark matches A and AB only. And then if we want to say match, the start of a sequence contains these letters ATG in exactly lowercase. We can put a circumflex at the front to indicate that's the start of the string we want to match. So this is in the middle, it won't match. There's other variations on this. So for example, we want to match a certain number of copies, like X copies. So X could be 2 or 3 or 4 of a regular expression. So we put this afterwards. So we might have A here and B there to use our previous example. So if we want to match that 2 times, we just put 2 inside here instead of X. So match AB occurring. If we want to have a particular number or a particular range of matches, we can put 2 values in here. So X comma Y, maybe 2 to 3 copies of that expression. If we put in a comma with nothing at the end, it's X to infinity of the expression. If we put these 3 words, letters in square brackets, what we're saying to Python is we're matching X or Y or Z. So any of these will match. In the same way, if we want to match any letter, instead of writing out every single letter of the alphabet, we can just have the A-Z. And then if we want to match a special character like a round bracket, these lose their special meaning inside these square brackets. You can just put them in there without a special character. So that's useful if we have a complex pattern to match. Then we have numbers as well. So if we put numbers in square brackets too, we'll match any of these numbers, any single digit set of numbers. If we want multiple digits, we have to put this pattern twice. So let's look at examples of these. So let's say we want to match ATG, ATG exactly twice. So we put in ATG and then put in the round brackets of 2 at the end. Of course, we could also just simply put in this string if you wanted to. Both will work in the same way. If you want to match TAA 2, 3, or 4 times, we can match, we'll match these different strings. So of course we could put in several different conditional statements to do the same thing, but maybe this is a more neat way of writing our code. If we have different things that you're matching, we can have separate matches, or we can put them together in this manner. So if AA pipe has a vertical line here, that means 4. So we're either matching AA or 3 or Z. So any of these matches will give it a value as true and return a positive match. If we want to match any 2-letter string, we can do that by putting A to Z twice. So any pair of letters will be matched there. If we put a dash and 1 comma, that will match a single dash or any number of dashes together. So 2, 3, 4, 5, 6, 7, up to infinite numbers of dashes. And for example, if we want to match 2 different digits here, we can put 2-digit combinations together in square brackets. And if we want to range it from being effectively 0 to 19, if we put 0-1 at the start, we'll match all those pairs of digits starting with the 0 at the start and 1 at the start. And 0 to 9 at the end means we're matching 0, 1, 2, 3 up to 9 as the second digit. So that will match 0, 0 to 1, 9. Finally, if you want to match a word separated by either special characters or letters, we can put \W to indicate that this is our word that we're matching. So you can see there's quite a lot of different tricks and things you can use for matching patterns. You don't need to use all of them or even to be aware of all of them, but you should just note that there are more efficient ways of writing pattern matches, and those will be useful for you. And like all of these, we'll talk about them more in the demonstration lab videos too. So there's lots of other functions that we can use in addition to what we had earlier, where we were talking about the replace function. We need to use the regular expression package. So we need to write this at the top of our script import or E to import that library. And that means if we have some sort of string to, like here, like an accession number, we can use this code rematch. So it's using this library, it's matching, and we're submitting to this function string2, and we're acting on it in this manner. So we're saying R in this particular match. So inside the code, these codes, we have a complex match. What this is indicating is that we have some word in the round brackets. So the round brackets are effectively ignored here. We have a word that we're matching, at least one word, and a digit at the end, at least one digit. So this can be many digits, 1, 2, 3, 4, 5, whatever number of digits, and they're separate by an underscore. So that means that we have a bunch of letters, underscore, and the digit, and we're matching this on the string. So what we're seeing is effectively a patch of letters followed by the underscore and the digits, just like we have here. So when we put this match into M1, we're assigning to M1, it is a special groups function where that match is stored. So we can access those match, and that groups has two entries printing NM and 123 at the end. So it stores the first part and the 123 as given by the round brackets here, whereas the underscore is not stored inside here. It's split effectively on that match. So we'll talk about this more in the demonstration app videos. So then to install that, remember you have to go to your PyCharm, go to settings, go to the project panel here, which you see down here, and go to the Python interpreter, and you'll see a list of packages you can add there. Hit the plus sign, search for RE instead of NumPy here, hit install package, and if you wait a bit, it'll eventually be installed. So that concludes our short video on regular expressions